everybody. Thank you for joining me on this last session of the first day. My name is Ian Waters. I'm with a company called ThousandEyes. For those of you who don't know ThousandEyes, we are a monitoring platform. We specialize in monitoring cloud and the cloud provider networks and the internet, as well as your private networks. So when you move to the cloud, you get full visibility of the end-to-end application journey your users are taking and are able to troubleshoot the cloud and the internet like they're your own networks. I'm not going to talk about us today. What I'm going to talk about is a piece of research that really illustrates the strength of what we can do. And that's the second piece of research on the state of the public cloud that we've released recently. And I've got quite a lot of content because it's just a teaser. So I'm going to skip through it quickly and hopefully it will give you a flavor. If you want to download the full report, it's at thousandeyes.com/cloud and hopefully it's of interest. So we talked a little bit about, I mentioned just a minute ago that we did this report last year. So let's have a little look at what's changed in that year. So last year we looked at the three major cloud providers. We looked at AWS, Azure and Google. This year we've added a few more things. We've added a bit on the AWS Global Accelerator, and we also added in a couple more cloud providers, so Alibabe Cloud and IBM. Just a slide or two on how we do it. We're fortunate because we run our own global monitoring software throughout the internet and the public cloud. We could take 98 global locations where we have our agents and 95 regions within the public cloud, and we could run that for a month, basically testing the performance of all those regions from all those locations and building a data set that runs to hundreds of millions of data points. We also tested inter-AZ and inter-region and inter-cloud and a range of other things. So there's a lot more on how we do it in the full report, but just to give you a flavor of some of the findings and hopefully as a teaser to download the full report. First question we asked is, are all the cloud provider backbones created equal? Some of the observations we made from the year before was around how different major cloud providers have different approaches to getting traffic onto their backbone. And this year we had a couple more providers. So we ranked these. We said, okay, from all the regions around the world, looking at the regional pairs and looking at the performance between those regional pairs, how did the suppliers do? How was it compared to just using the internet versus getting on those provider backbones? And what we actually found was IBM came out the best. Actually 97% of their regional pairs, it was better to go across the backbone than it was across the public internet. Alibaba or Ali Cloud came out slightly down, 15% of their regional pairs. Actually, it was easier to go across the public internet than it was to use their backbone. But again, you know, even in that worst case scenario, we're still saying 85% of the cases it's better to use the backbone. So these are strong cloud providers with strong regional backbones and strong performance. We also found that there are a couple of major camps. There are providers who fall into being backbone friendly. They like to get the traffic from the user onto their network as quickly as possible. So they've built their edge out to the user. That's Azure and Google. And there are a couple that are quite internet heavy. They leverage a lot of the public internet to get that traffic across to wherever their edge is, quite a long way away from the user. And Alibaba and AWS fell into those categories. There's quite a bit of crossover. We actually looked at IBM. IBM fell somewhere in between. IBM, we found that in certain locations, such as the US, they tended to favor getting customers onto the backbone quickly. However, in certain regions of the world, such as India, they were more internet heavy. There was a lot more internet transit involved before they actually hit the IBM edge. So again, you can delve into the detail behind all of these in the full report. One of the things that AWS announced in the interim was something called their Global Accelerator, which is something you pay for to get onto the AWS backbone sooner, more quickly, with the assumption that you're going to get improved performance. So we dug into that a little bit as well. And this is the first of the findings that sort of says, broadly things are right, but it really does depend where in the world you're looking at. You know, where are your users, where are they trying to access the service? We actually found that your mileage may vary on AWS Global Accelerator. In South Korea, there was a strong performance. We actually had a performance of 80 milliseconds. and a performance in jitter increased. But actually, in the other parts of the world, it wasn't so clean cut. Actually, in Bangalore, getting onto the accelerator versus going over the public internet meant you had a worse performance. So effectively, you're paying for 100 milliseconds greater latency to use the AWS backbone. And even in parts of the world where you'd expect it to be super fast, such as San Francisco, the difference was really negligible. We're looking at 7 milliseconds difference between monetizing and paying to get on the backbone versus just using the public internet. So again, it really illustrates that you need to have data to back up some of the decisions you're making based on a regional basis. But the next question is, are all these backbones really a panacea for performance? One of the things we pulled out last year was around GCP. And when we looked at GCP performance between Europe and Asia, what we actually discovered was that there was no direct connection between Europe and India. So users from Europe trying to access India were actually going all the way around the world to get to Mumbai. And that was resulting in something like a 3 times greater latency on GCP versus using the public internet. Now, Google are fixing this. They're through the first phase of fixing this and putting that connection in place. So this will soon be remedied. But it's actually, at the time we did the report this year, only in the last month or two, it was still actually an issue for GCP users. We also saw that Azure was generally improving their performance. On the left-hand side of the chart, you saw in Sydney, the sort of reddish bar is last year, the bluish bar is this year. In terms of latencies and variation of latencies, for that Sydney region, Azure had improved 50% year over year. But again, it's not clean cut, it sort of depends what you're looking at. In India, we actually saw a 30% decrease in that performance, in that latency variation. So again, it really points to trying to be able to have a data-driven approach in the parts of the world you care about. The final piece we looked at, and again, I'm just doing this at a high level, is around China. We added Alibaba Cloud. The assumption would be that maybe Alibaba gets a bit of a free pass through some of the firewall and maybe their performance is better there. So we wanted to dig into that a little bit. So the first thing we looked at was packet loss. So trying to get to India from different parts of the world. And we saw actually that all providers coming from China through the firewall were paying something of a tax. They were all hitting a spike in packet loss. But actually Alibaba and AliCloud weren't excluded from that. They were pretty much in amongst the main group. So everybody coming through that firewall is getting up to around a 4%, 5% packet loss as they traverse it. And then when we looked at some of the regions, a lot of our customers think about what region should they be breaking out through. Should it be Hong Kong? Should it be Singapore? Should it be India? When we looked at the regions, Alibaba was slightly faster in both Hong Kong and Singapore, but there wasn't much in it compared to Azure. And when you looked at India as an example, there were faster alternatives. So again, just a high level point, but we weren't necessarily seeing some of that, maybe the free pass that we expected for AliCloud. And all of this really led us to a few conclusions. So just to wrap up with a few conclusions, starting with data is key, because we see that, in some parts of the world, getting on the backbone is great. It speeds things up. In other parts of the world, it might not necessarily. Depending on your cloud, the regional pairs staying on the backbone might be better to get better performance within those regional pairs. In other parts, it might not. In some parts of the world, Azure has improved. In other parts, it's got slightly worse. So having that granularity of data is key. Having that readiness cycle so that you actually know what performance is going to be before you start deploying, so you can test in advance and actually work things out, is also key. And ultimately, having data to drive that accountability is also key. So that's all I wanted to share for today. Hopefully it's a little bit of a taster for the report. If you want to go to ThousandEyes.com/cloud to download the full report, please do. Otherwise, come and see us. Thank you.